Welcome to Real GMAT Problems, episode 25. Doing real GMAT problems is one of the best ways to make test day easier, so let's talk through a few examples. The problems we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that you'll see there. The official guide contains retired questions that have appeared on past GMAT exams. So these are going to be very representative of the kinds of questions you'll see on your official GMAT. I'll give you a chance to work through these solutions on your own if you'd like, and then I'll discuss my thoughts for what to take away from each question. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it if you're on the go. You might not be able to execute all the steps in your head, but just do your best. I think you'll find it a very productive use of time and energy. If you are in a situation where you can write things down, then I highly recommend that. Let's go. This is problem number 90. The problem says, at the rate of m, as in the letter m, at the rate of m meters per s, as in the letter s, at the rate of m meters per s seconds, how many meters does a cyclist travel in x minutes? I'll read that again. We got three variables here. At the rate of m meters per s seconds, how many meters does a cyclist travel in x, the letter x, minutes? Option A is m divided by s times x. Option B is m times the fraction x divided by s. Option C is 60 times the fraction m divided by x times s. So that's 60 multiplied by, in parentheses, m divided by x times s. Option D is 60 times m times the fraction s divided by x. And option E is 60 times m times the fraction x divided by s. Again, I recommend pausing and trying to sort through the solution on your own. I'm just going to dive right into the solution so we don't have a bunch of dead air here. It's definitely a really tricky problem for a lot of folks. We've got about 20% of us missing this, and you can even watch Sal Khan of the Great Khan Academy make a mistake on this problem and actually accuse the exam of writing an incorrect problem before he ultimately realized that he has misread the problem and needs to set it up again. So it can be a very frustrating situation. If you've got super geniuses like him struggling with questions, then you definitely know you've got some difficult traps on your hands. So let's talk about how you can set yourself up for success on these types of questions that involve unit change and a good number of variables. There are a few different approaches that I think work well here. You can use standard algebra. You can plug in numbers, because notice you have a bunch of variables in the answer choices. And if you're not sure how to plug in numbers, we've got a specific episode on that in the feed. It's from a few years ago. So if you know how to search the feed, I recommend that. If you don't know how to search the feed, just send us a DM at the GMAT strategy on current social channels and we'll get you a link. And there's also the opportunity to just step through the problem one like logical piece at a time, almost like treating it like a story rather than a math question. And all of those work very well. And each of you probably have a different preference. I've given demonstrations of all of those solution paths actually on past problems in this series. So if you've been following along, you should have the tools to figure out which one is the best for you. But if you haven't been following along, perhaps obviously I recommend listening to the episodes. They will probably really help you out with having a variety of approaches that you can throw at this question. And later in today's lesson, we'll get into some alternate approaches as well. But what I want to say about this problem is, regardless of which path you take, there are a few concepts that I think you're going to find valuable. So these concepts that I'm really going to emphasize in this problem today are going to transcend whichever specific technique you use. And that's part of the reason I'm going to focus on those rather than the specific strategy. And we've talked about that a lot in the past, like I just said. So these techniques should really help you out no matter which strategic choice you make. What I'm going to do is I'm just going to use a standard algebra approach to demonstrate. But again, I think you'll find that the concepts that I'm going to emphasize are very relevant to any strategic approach. The good news about algebra here is that the variables are already defined for us. That's kind of nice. I've talked about this a lot in the past as well, but let me just briefly reiterate that I think it's a very, very good idea to write down what each variable represents when you have variables in word problems like this one. When you've got a bunch of variables in a more abstract, pure algebra question that's not really about like real world quantities like this question is, then you don't really have to define your variables at all because X just doesn't even necessarily represent anything. It's just a general unknown in those kind of abstract algebra questions. But in situations like this one, where the variables definitely represent some kind of physical or real world quantity, that's when I recommend making sure that you are defining your variables quite clearly by writing them down. So I'm going to give an example of that. I know that might sound like I'm really stressing like a very small thing, and maybe I am, but what you've probably noticed in the quant section, if you've been studying for any length of time, is these details just really matter. I tried to gloss over the details myself when I was studying back in the day, and I suffered so much. And so I'm just trying to save you that pain by just communicating to the best of my abilities so that you don't have to experience the pain for yourself, just communicating it to you here. Like, this should make a very positive difference for you, even though it might seem like irrelevant or just like it couldn't possibly matter. So um, let's just give an example. I might write something like m equals meters. Like it can be that simple. I'm not talking about like some very elaborate thing here. I would probably write s equals seconds and I would write x equals minutes the cyclist travels or something like that. Some kind of shorthand of that. I would probably also write that the cyclist travels at a rate of m over s meters per second, which is what the word per means, per. So in the original problem, it says m meters per s seconds. If you're not familiar with that, that's worth memorizing and understanding. When you see the word per, that always means create a fraction where what comes before per is in the numerator and what comes after per is in the denominator. A lot of you have like an intuitive sense of how that works, and you're not even going to have to think about it. Some of you might have to think about that deeply and also might have to memorize it. And I have seen a lot of people make that mistake in the past, especially if English isn't your first language. That's definitely a unique challenge with this exam for a lot of folks. But it's all learnable, and I'll talk about that more later because there's definitely a vocab issue in a later question as well that it looks like a lot of people are falling for, and it's just a learnable thing like any other skill here. And nobody said it was going to be easy, but I think we would basically all agree that the payout is more than worth the investment of time and energy to build up your skills. So trying to help out with that with the word per, I definitely see a lot of people make that mistake. So if if you want to make a quick note to self there to memorize that later, then by all means do so. Now that we've got all our quantities and variables written down, we just want to organize them in a productive way. So what I usually recommend for rates questions is the formula R times T equals D. You'll almost always be dealing with that formula in some way, shape, or form anytime a problem uses the word rate like this one does. So in the R times T equals D formula, R stands for rate, T stands for time, and D stands for distance. So rate times time always equals distance. Think about going 60 miles an hour or 100 kilometers an hour for 2 hours. You would probably fairly intuitively multiply that to get a distance. And that formula is like the backbone of virtually all rates questions on the GMAT. Now, I'm not trying to make it seem easier than it is because a lot of people struggle with rates questions, and I'm sure we'll have a lot to say about those as time goes on. But what I'm going to start you with here is a framework, like I was talking about earlier, that I think will help you regardless of what types of specific approaches you use on rates questions going forward. So you'll see quite a few people recommend making a chart out of this formula, where the top of the chart is the formula, R times T equals D, and then you'll see other people write it as D equals R times T. Both work. It's the same concept. You can feel free to use whatever is easiest or more familiar to you. What we then do is we make each term in the formula like a header for a column in the chart. So you would write all the rates under the R variable. You would write all the times under the T variable. You would write all the distances under the D variable. And it becomes almost like a table or like a matrix. And yeah, I'm a fan of this. I think it works extremely well. There's definitely other ways of organizing information in rates questions, so I don't want to make it seem like that's like the only way to do it. But I've had a lot of success with it. I've seen people have a lot of success with it. And in a general public format like this, where I'm not coaching you one-on-one with like deep understanding of your specific skill sets and strengths and weaknesses, then I think this is probably the best general recommendation that we can make. Um, it's usually really helpful for organizing questions like this one. If you have multiple trains moving at the same time, or if you have three people running in a race, or things like that, then that table is a really, really great way. I've seen it really help a lot of people wrap their minds around complex questions where you have multiple people working and moving. Um, Having said that, I think it's still useful enough that it's worth using even in questions like this, where you have only one instance of the formula and only one person moving. So basically, what I'm recommending is that you use that table 100% of the time when you're on rates questions. It might not be enough to get you all the way to the solution, but it almost certainly is going to keep you from making mistakes and make it easier to make connections between disparate pieces of information, which is often a big challenge for people on rates questions. So that's what I'm going to do here. I'm just going to write R times T equals D across the top of my hypothetical scratch paper here. And then under R, I would write M over S, meters per second. And I strongly recommend writing units into the chart if you're using this. That's not going to come as any surprise to you if you've been following the series for a while. You know I'm big on clarity of scratch work and writing units and what things represent in English when you're doing word problems. And I think you'll become a big fan of it too if you give it a fair shake. It will probably get you a lot more questions right, which, as we are probably all aware, leads to very, very wonderful things after the test. So under T, so sorry, to reiterate, under R, I'm going to write R times T equals D across the top. I'm going to write under R, M over S meters per second. And under T, I'm going to write X minutes. And there I'm just writing what they've already given me. I'm not like thinking deeply about that. I'm just using this system to organize what's given. And the nice thing about that is that signals me at some point that I'm going to want to multiply those two things together to generate a distance. And that's good news because that is what this question is asking me to produce. It's asking me how many meters the cyclist travels. Now, there's only one little hiccup here, which is we have different units for the rate, which is in seconds, and different units for the time, which is in minutes. Now, all we need to do there is convert to a common unit. And in most cases, it won't really matter much whether you choose seconds or minutes. So you can feel free to go with whichever makes the most sense to you. But just make sure you have everything in common units before combining the pieces of information. If you try to do the seconds times the minutes, it's usually going to just create a mess. So in this case, for me personally, it's going to be easier to convert X minutes into seconds rather than convert M over S meters per second into minutes. And that's just because X is one term, but M over S has two terms. So I'm really thinking that simply about which one to use for myself. And I'm a big fan of the less is more approach. So I'm going to go with converting the single term since I'm less likely to make a mistake there. So just to be clear, you can make the conversion any way you want. But what I like to do is I like to write a fraction with the new unit on top and the unit I want to get rid of on the bottom. That's how I like to think about making unit conversions. So I want the unit that I want to wind up with in the top of the fraction, and I want to write the unit I want to get rid of in the bottom of the fraction. So in this case, that's going to be 60 seconds over 1 minute. So what I'm using there is just a common conversion factor. Most of you are probably aware that there's 60 seconds in 1 minute. But you might not be aware that it's a good idea to write that as a fraction with seconds on the top and minutes on the bottom if you want to convert minutes into seconds. Many of you will be very aware of that, of course, but you're probably not experiencing too much friction at that step in the problem if that's you. So I'm more talking to the people who struggle with unit change. That's a good little system that you can use. And again, in a general setting, that's going to work extremely well. So just to reiterate, the unit that I want to convert to, which is seconds, is in the top in the numerator, and the unit that I want to get rid of, minutes, is in the bottom in the denominator of the fraction. So once I've got that fraction, I can multiply the thing I want to convert, which in this case is X minutes, by that fraction. And that's going to cancel out the units that I want to get rid of. So you can imagine writing it as X minutes over 1 times 60 seconds over 1 minute. The unit minutes, if you think about that as like a number that's being multiplied in the fraction, that's going to cancel out. And then you'll be left with the desired unit, which is seconds. So if you're not sure what I mean by canceling out, or if you want to get a little bit more clear on how that works and how to do it well, then we've got a fractions episode in the Math Basics series that's linked in the description of this episode. And that should really help you upskill or reskill with fractions and canceling. If we were to perform that operation I just described, then we would get that X minutes is X times 60 seconds. Now, again, for some of you, that might have just been comically easy. That's awesome. If that's you, definitely be grateful that that's easy for you. If that's hard for you and you struggle with unit conversions, I would recommend re-listening to what I just said and make a note to self for the future. Now, if we make that conversion, in the chart, I usually just like to make a row beneath the top row and just write everything in the newly made form. So that would be m over s meters per second times 60x seconds. And then now I've got everything in a nice clean format that I can use where I'm unlikely to make a mistake computing the actual numbers. So let's go ahead and make that computation. M over S meters per second times 60x seconds means the seconds unit is going to cancel. We'll be left with meters. That makes sense because we're solving for a distance. And then in the numerator of that fraction, I'm going to have M times 60 times X. And in the denominator, I'm going to have S, the letter S. And that's option E as an echo. That leads us directly to the answer that we want to pick. Now, we definitely have a lot of people missing this. We got a lot of people picking B, we've got a lot of people picking C, and we've got a lot of people picking D, which are all very similar to the right answer, but obviously not exactly right. And most likely, people are just having some organizational challenges on the problem because like they kind of have all the right elements there, but they're in the wrong order. Like they flipped the fraction upside down or something like that, or they mixed up the units. And that could be coming from some reading mistakes, which we've talked a lot about in the past as well. And if you made that type of mistake on this problem, I'd really recommend virtually any earlier episode of this series where I pretty much talk at length every single episode about how to avoid those kinds of mistakes. And I think I've talked about them so much that I'm ready to just move on to new things. But if you're not ready to move on and you want some help with that, then I've got, let's see, 24 episodes worth of help there for you. So by all means, please take advantage. For this specific problem, though, let's focus on the unit conversion piece and how to organize rates questions in general, which is kind of like the next level up once you get your reading and your writing and like all those kinds of mistakes to be locked down. So if you didn't have a good system for either of those things, hopefully you do now. I talked at length about the rate chart. I talked at length about my approach to unit conversions. And again, if I were coaching you one-on-one and I knew all your specific strengths and weaknesses and had all the context on your academic history, maybe I would make slightly different recommendations or very different recommendations. But if I had very little context on your situation, I would make these recommendations because they're very, very unlikely to work. Even if there might be like a more efficient way for you to do it, this is going to be the bread and butter. And if you're the kind of person who's in a situation where you just don't want that kind of guidance from a professional, or you have to do this self-study on your own and have to do it for free, then this should for sure get the job done at a really, really high level. And yeah, I've talked at length about how to get different types of support. There's an episode from the beginning of this year titled How to Start Your GMAT Studies in 2025. And that'll give you a full breakdown of like all the available paid options that I recommend in the industry and how to make a good decision based on your budget there. So if you want help choosing a provider and you're not going to just do it for free, I also do give a sketch of a free plan there. And we have other free study plans. I think there's a couple episodes called Study Plan in the feed. That's there for you as well. So regardless of where you are on the budgetary spectrum, you should be able to get some good quality help and some good quality advice from those episodes. So just to reiterate, I recommend using a chart with R times T equals D across the top when you see rates presented in quant questions. And I recommend using fractions to change units with the desired unit in the numerator and the unit you want to get rid of in the denominator. And then when you multiply, you should wind up with the correct units. So that covers most of what I think is really key in this problem. If you're curious about how some of the other approaches might look, or you have questions about anything that I'm presenting here, just feel free to shoot us a DM anytime at the GMAT Strategy on current social channels, or you can email us. Our email address is contact, CONTACT, at thegmatstrategy.com. And we can return to this problem in future episodes if enough of you ask for alternate solutions and talk through all those solutions. But I didn't want to just have a whole, long 30, 45-minute episode focused on one problem. I just thought that might be like a little redundant. So in the meantime, I'd recommend just making a quick note if there's anything you want to remember from that one, and then we'll try another one. Okay, this is problem number 92. The problem says, in a certain furniture store, Each week, Nancy earns a salary of $240 plus 5% of the amount of her total sales that exceed $800 for the week. If Nancy earned a total of $450 one week, what were her total sales that week? Let me read that again. In a certain furniture store, each week Nancy earns a salary of $240 plus 5% of the amount of her total sales that exceed $800 for the week. If Nancy earned a total of $450 one week, what were her total sales that week? Option A is $2,200. Option B is $3,450. Option C is $4,200. Option D is $4,250. And option E is $5,000. Again, recommend pausing if you want some time to work through this one. Great question to practice your word translation skills and to some extent equation skills also. About 25% of us end up missing this question. So let's have a real talk here about how you can keep that from happening. A good solution to a word problem usually begins with a solid setup, meaning you're clear on what's being given and what's being asked. So I definitely recommend writing that down per my recommendations in many of these episodes and the previous problem. So we're asked to solve for her total sales, so I would definitely note that, usually by just writing something simple like total sales equals question mark or something like that. She earns a base salary of $240, so I would note that. And she also gets a commission of 5% on her total sales volume, but only the sales volume greater than $800. And as you might imagine, that can be a big sticking point for a lot of folks here. So I would note both. It's a good time to make an important point that some people are able to bundle all of that into an equation relatively easily right after reading, while other people really, really struggle to do that. And I would say that the vast majority of people are in the struggle category. If you're one of those people who struggles to create equations from word problems, or you find you often make mistakes translating word problems into equations, then I found that it's a good idea to make a step between those two things. So there's like the reading, and then there's the math, and then we're going to make a step between the reading and the math. It's almost like a step in the right direction, but not to the end result, where you're just going to note what's given and or the mathematical relationships in English or like some combination of English and math, instead of putting this pressure on yourself to go straight to the equation and then solving. Now, if you are that person who can just go straight to the equation and get these questions right all the time, that is for sure ideal. And many people are very jealous of your ability to do that. So definitely capitalize on that and enjoy that. But for those of you who struggle, this should really help out. So when I wrote the question, like I was just telling you, I wrote total sales equals question mark. That's kind of like half math, half English. That's what I'm recommending here. So I wouldn't hesitate to do something similar with the given information. For example, I might write something like salary equals 240. Commission equals 5% after $800. Total earned equals $450. And again, it's not really math, but it's not really only English. And I think a lot of people feel like, how's that going to help me? Like that's not really useful. Like it's not what I'm supposed to be doing with my time. I don't have time to do that. I got to get straight to the equation. But think about it. If you force yourself to go straight to the equation and you're not good at making that happen, is that a good use of time? Now you're just getting quickly to the wrong answer. That's probably not going to help out. So instead, what you want to do is just have a stepping stone that then can get you to the equation a little bit easier. So what I like about this like half math, half English approach is I'm unlikely to make a mistake in the logic this way. Whereas if I go straight to the equation, you'll see a lot of people make a mistake in the logic, and that's very backed up by the numbers of wrong answer choices on this one, and I'll share that more in a second. But also what I like about this is it requires a little bit less brain power than going straight to an equation for a lot of people. So I'm unlikely to write something down wrong and then do a bunch of correct math on the wrong thing, which is a huge, 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 huge problem for people with word problems on the exam, especially under time pressure. So while it might seem like a waste of time, and it might be a waste of time for certain people, I've actually found that a lot of people can finish questions faster using this kind of layered step-by-step approach, because by the time they go to create the equation, they've already processed some of the logic, and they're almost certainly dealing with accurate quantities. So it just makes it much harder to make a mistake setting up the equation. Again, just want to emphasize this is not critical. I'm not saying everybody needs to do this. But if you struggle to set up word problems or you're often making mistakes when you set them up and you're not doing something like what I just walked you through, then that's almost certainly going to make a very positive difference, and it can be a really valuable way to improve your results there. So now that we've got the basics accounted for, we'll start putting the pieces together and we'll solve it. So we know she earns $240 no matter what, but obviously she earned more than that if she took home $450. So we're going to have to add the commission to the starting salary of $240. We know she makes 5% commission, but that's not 5% of the total sales. It's only 5% of the sales after 800. So to represent that, if I want to move from where I am to an equation, I might use something like a variable like X to represent her total sales. And then I would write X minus 800 to represent the amount that she earns the commission on, which is the after 800 part. So, if she sold 2 grand worth of stuff, then she's only going to get commission on 1,200 of that. So I would represent that mathematically as X minus 800. If I want 5% of that value, I can express that as 5 over 100 times in parentheses X minus 800. And if you're not sure how to use parentheses or how to set up equations, well, we've got a math basics episode called PEMDAS that'll help you reskill with parentheses if it's been a minute and you're just starting your studies. And we've also got an episode on equations and how to get good at handling those. So if I do 5 over 100 times X minus 800 in parentheses, that's going to give me 5% of the sales beyond the first $800 she sells, which is what I want. To turn that into equation form, I would have 240, which is the salary, plus 5 over 100 times X minus 800. That's the commission. And if I add all that up, that should equal 450. So I can just write 240 plus 5 over 100 times X minus 800 equals 450, and then I can solve. So again, that's that staircased, stepwise from reading only English to half math, half English to all math. And I think you'll find that really, really valuable if you struggle with these kind of word translation questions. Let's go ahead and solve. We'll subtract 240 from both sides. There's a million ways to organize the math here, so I'm just giving you like one example, but however you want to do this in whatever order works. Subtract 240 from both sides. That gets me 5 over 100 times X minus 800 in parentheses equals 210. That's 450 minus 240. From there, I'd probably multiply both sides by 100 over 5 to get rid of the 5 over 100 on the left side. So that would give me X minus 800 equals 210 times 100 over 5. Now, 100 over 5 is just 20. So effectively, we have X minus 800 on the left equals 210 times 20 on the right. I'd probably do some long multiplication on the right-hand side just so I don't make a mistake. We got a math basics episode on long multiplication below if you don't remember how to do that or you want to get better at it. And if I did that long multiplication accurately, I would get 4,200. So I would have X minus 800 on the left equals 4,200 on the right. I can add 800 to both sides in order to isolate X, and that's going to get me X equals 5,000, which is our correct answer, and also option E as in echo. Again, if you have questions on any of this stuff, just reach out anytime at the GMAT Strategy on current social channels if you want to DM, contact at thegmatstrategy.com if you want to email. Otherwise, let's explore why so many people are going for option C as in Charlie. 21% of us picked that answer. And that answer, you might recall, is 4,200. And that is the answer that you would get if you just left out the minus 800 part completely and you just assume that she gets paid 5% of her total sales, rather than what the problem tells us, which is 5% of the total sales that exceed 800 for the week. Now, I can definitely see some folks getting confused about that phrase, that exceed, and thinking that as long as she sells more than $800, then she's going to get 5% of the sales. Like that, I could really see myself doing something like that. I could see other people doing it too. So that could be a vocabulary issue. That can definitely happen. A lot of us have vocab issues on the exam. Again, if English is not your first language, that's totally fine. It's just another problem for you to solve in this prep process. You just make some flashcards or you make a study sheet and just keep track of the vocabulary that comes up in questions that you don't know. And over the course of a couple weeks, you'll build up the vocabulary you need. The vocabulary on the GMAT is not terribly diverse and complex. There's definitely some stuff to learn for folks, but it's it's you've probably memorized more vocabulary for tests that were way less impactful for your career than this one's going to be. Let's put it that way. So it's a very doable thing. I'm not saying it's going to be easy or that you're going to love it, but just saying it's doable. So I'd recommend that there if it was just a vocab issue or an understanding issue. If it was a reading issue and you just were going too fast or you weren't careful enough, or a writing issue like you forgot to write it down, even though you read it well, then I already talked about how I've got tons of tips for that in past episodes of this Real GMAT question series. So that'll all help a ton. Yeah, just side note, I've helped tons of folks who felt English was not like their greatest strength over the years, and they've all done extremely well on the exam and gotten into great schools. So again, not saying it's going to be easy or fun, but just saying it's totally doable. You can do it too if you're in that situation. Having said all that, my guess is that the significant majority of people do understand what the problem says when it says exceeds 800, and they just forget to include that in their equation. That would be my guess after seeing thousands of people solve this problem. So that's why I recommend writing things down in English first and then putting things into the equation after that in between step. It usually cuts down on those kinds of mistakes. So I'm very hopeful that that's going to help everyone out. Even if you don't struggle with word problems, you might find that small adjustment helps make things easier on more complicated questions. And if there's a note to self to make here for you, then I recommend sending yourself a message to recall that and integrate it into your studies later. For now, let's try one more question. This is problem 95. The problem says a certain company retirement plan has a quote unquote rule of 70 provision that allows an employee to retire when the employee's age plus years of employment with the company total at least 70. In what year could a female employee hired in 1986 on her 32nd birthday first be eligible to retire under this provision? I'll read that again. A certain company has a retirement plan provision that allows an employee to retire when the employee's age plus years of employment with the company total at least 70. In what year could a female employee hired in 1986 on her 32nd birthday first be eligible to retire under this provision? Option A is 2003. Option B is 2004. Option C is 2005. Option D is 2006. And option E is 2007. Again, recommend pausing, recommend writing down as much as you can, or visualize what you would write down. Interesting question here in that a good number of us get turned around on it. About 23% of us miss this one. So let's talk through a couple different approaches and make sure you're comfortable on test day. We can definitely use algebra here in some interesting ways. And of course, it's also a situation where you can use the tip I gave on the previous question in order to avoid mistakes when you're setting the question up. But it's also a good opportunity to explore plugging in the answers and guessing and testing. So let's do that since we just walked through an algebraic approach on the previous question. So just want to mix this up here. Overall, I've found that guessing and testing the answers is an approach that a lot of students resist. And I'm not totally sure why. I think some of it could be just conditioning, like we've all just done so much algebra in our lives that deviating from algebra just feels wrong. Or maybe there's like some other fears that the technique won't always work. And I think all of that's justified. Like sometimes the technique doesn't work or it just doesn't work super well. For example, like if each answer choice represents a sum or product of numbers, there can end up being way too many combinations to test, and plugging in the answers usually is like a really bad idea in those situations. But in this problem, it's not too bad because each answer just represents one thing in the problem, the year where she's eligible to take advantage of the retirement plan. So this is actually a good type of situation where you can plug in the answers and guess and test. Now, usually this technique works best when you're unsure how to do the algebra or you just don't want to do algebra. So if you find yourself on a word problem and you're not sure how to set it up, just ask yourself if plugging in the answers could help. Again, sometimes it does and sometimes it doesn't, but it's worth at least considering it since it can be super helpful on a lot of questions that would otherwise be really, really hard to do the math on. So to be clear, I don't think this question is too tough with algebra. But obviously, a lot of people are getting turned around on it and making mistakes. So because I just gave you some advice, about translations and setting up equations and executing well on the previous problem, and we've done tons of algebra in this series. Let's just use this problem as an opportunity to expand your skill set and give you a few more options to succeed if the going gets tough with a more traditional approach. When you're plugging in the answers, the most important thing to do is be organized with what you write down. And it's probably not a surprise to hear me say that if you've been following the show for some time. But that does not make it any less true. So that's definitely important. There's a lot of other advice out there about which answers to start with and some interesting probability math to support those assertions. And nothing's wrong with that. But I've found that the best general advice that I can give in this like public format again, where I may not know much about your situation, is just start with the answer that's going to be the easiest to work with. That's generally a way that just works really, really well. And it's nice and simple. So that's what I'm going to do here. Imagine that I've already taken my own advice from the previous question and I've written what's given and asked, and mostly like half math, half English. Let's say I've like already done that step. And then let's pretend I'm not really sure how to set up the algebra. Like I'm kind of getting stuck. And so I'm just going to plug in the answers and see if that helps me. I'll take a look at the answer options first, and then I'll double check what the question asks for just to make sure the answers don't represent something weird or complicated that's going to make the math hard to execute. But that checks out fine because we're just asked for a year and the numbers in the answers aren't too complicated. They're just years. Now, going back to what the problem gives me, we're starting in 1986. And if I scan the answers, it looks like the easiest number to deal with is going to be 2006, because that's just 20 years after she's hired, which is a nice round number. So I'm just going to start there because that seems easiest to me. So I'll think about what that means. If I assume the answer is 2006, then she's worked at the company for 20 years. So that solves that piece for me. We know that she was hired when she was 32. And if she's been working there for 20 years since that time, now she's 52. All I have to do is add the years she's worked there, 20, to her age, 52, and that gets me a total of 72. And that's good news because that means I'm close to the right answer. It's not exactly the right answer because the problem says she's eligible to retire when the sum of her years of employment and her age is 70. So I'm at 72. So I'm a little higher than I need to be. So while 2006 is just a bit later than the earliest, I'm not that far off with my first guess. So that's good news. I'm kind of like in the ballpark. Again, just want to emphasize, I'm not necessarily recommending you solve this problem this exact way. I'm just recommending that you be familiar with solving questions in this way, just in case the standard algebra approach ends up being too tough for you on any particular problem. So we're close, but a little too high. So let's drop down to 2004 and let's see what happens there. I know because I started 20 years after she was hired that 2 years earlier would be 18 years at the company. She was hired when she was 32, so 18 years later she'd be 50. Her age, 50, plus her working years, 18, would be 68. So that's too early. So she can't retire there. But that's great news because there's only one option between 2004, which is too low, and 2006, which is too high. So I can confidently pick 2005, which is option C as in Charlie, and also happens to be the correct answer. So you're welcome to test out the math and the logic with 2005 if you want. But as you get more practice with this technique, I think you'll feel plenty comfortable making that kind of move just by knowing 2004 is too low and 2006 is too high. But feel free to test it out for practice if that's helpful. So that way of solving can make a lot of people nervous. And that's totally cool. You can always default to using algebra 100% of the time if you want to, and plenty of people have gotten awesome scores doing that. But I do want you to know that you do not have to default to algebra 100% of the time if you don't want to, or you just find that that's limiting your results. And I think it's a good example and a good time to discuss some alternatives that you might find useful, given how much algebra we've done in this series. So if you want to try this one out with algebra to compare, by all means, please do. If you have questions about any of this, reach out anytime. And I would recommend making a note to self as usual. We will be back soon with more tips that will hopefully seriously help you reach your goals and dreams faster. In the meantime, if you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.